about this one. This is what actually you have to send me the, if any emergency case, you have to call me. And you know that earlier you had this, uh, sorry, you have, earlier you have this number and everything. So you keep the number and the email address. Can you see
Yes,
better?
sir.
Yeah, all of you
Yes, sir. Better.
immediately take a snapshot. This is the clear picture. Take a snapshot. I'm telling you again, you cannot claim, sir, network fail, I could not see the question paper. I will not accept it. I'm telling you again, everybody get a snapshot first and then you start. Okay? And you remember, hey, listen, somebody's talking. Sumaya, all
Yes,
silent.
sorry, sir.
Yes, silent. Uh, and just within 15 minutes, you have to answer, and nobody should drop the classroom. Everybody should stay back and answer. And check your name, ID number, everything written properly. Okay, I already get the snapshot of all your presence. Nobody should leave it. I will be in trouble if anybody leave the classroom. Just answer, submit, and then go. If someone dropped, I'll just catch it. Please do not drop. If you have any problem that you cannot connect within the classroom, you must call me at my mobile. The guy who came late, just take the snapshot of the question and start immediately. Already 7 minutes gone. Another 8 minutes. You have last 4 minutes. It's 9:11. Have last 2 minutes. Nine 13. Last 2 minutes.
Assalamualaikum, sir.
Some have done.
Sir, is this including sending time?
Now,
You're talking
after
2 minutes.
3 minutes, I'm sorry. After our time's over. Now you have last 5 minutes to send it to me by email, just for processing time. Okay, processing time. Last 5 minutes. That means you have to send me by email now. Okay. Uh, get the snapshot in your mobile and send it to my email address akmam.azad@gmail.com. Send it to me. I am watching the email, so if it comes, I'll let you know that it is there. Anybody send me? Just tell me.
So I have sent, sir.
You send me at what email?
Sir, at your email,
Gmail.com.
Sir, I have sent.
Okay, just let me check. I think I didn't
akmam
get. Yeah,
dot.
the email address I have shown at the beginning at my gmail.com. Okay.
Sir, I
Yeah.
have sent.
Okay. I think
Sir,
some
but
of
I
you.
have sent the same thing twice,
Okay,
sir.
I am going to, no,
Sir,
don't send twice, please. Send once, I think better. Try to avoid unless any emergency. Okay, I'm going to call your name. You listen. If you your name is here, then it's all right. Okay,
Okay.
I'm going to call your name if you have sent it or not. What do you call that? Kainat Nipa. Oh no, this is not Kainat. Kainat, have you sent it? No. Just a minute. Not Kainat. I'm sorry. This is not Kainat Nipa. Okay, now it started from here. Rahatul Jannat. Rahatul Jannat here.
Yes, sir. Yes.
Okay, your one I have received. Maimuna Pranti. Hey, you have to respond. Maimuna Pranti.
Yes, sir. Yes, sir.
Okay,
Yes, sir.
good. Aniruddha Barman.
Yes, sir.
Good. Then Rakin
Yes,
Yusuf.
sir.
Rakin Yusuf.
Yes, sir. Yes, sir.
Good. Sadia
Yes, sir.
Sabah. Sadia Sabah.
Yes, sir.
Good. I received your one. Okay. Rabbul Khan. Hey, Rabbul Khan here.
Yes, sir.
Okay, I received your one. Then Shafim Jur Khan. Shafi Monjur
Yes,
Khan.
sir, I have sent it.
Shafi Monjur Khan, yep.
Yes, sir.
I received it. Adnan Islam here.
Yes, sir.
Okay, I received your one. Aditya Das.
Yes, sir.
Okay, I received your one. Farida Yasmin. Farida.
Sent on the email name using
Okay.
the name for the Yasmin.
Yeah, don't talk. Listen to me. Farida is here. Farida Yasmin. Hey, Duck. Farida Yasmin here. I'll drop it. Someone else maybe. Is it? Is Farida Yasmin here? Okay. Anyway, I'll check that one. Farida Yasmin. Then, huh? Then Musa. No, not Musa. What's his name? Muhammad Mahabub Ali. Muhammad Mahabub Ali. Muhammad Mahabub Ali. Hey, Duck. Why are you not responding? Strange people. Okay, I'm just reading the name. You just check it. Mahabub, Shifat, Sumaya Majid Chaudhuri, Jaharat.
Yes, sir.
Jaharat Tabassum, Saud Norman.
Yes, sir.
Yeah, Saud
Yes,
Norman,
sir.
Fairuz Binte Farooq.
Yes,
Abdus-
sir.
Yeah, just listen. And if your name is not there, then tell me. Abdus Samad Bhuya, Saif Haq, Al Amin Patwari, Rokon Jaman, Pial, Mustafa Al Mamun, Muhammad Hasibul Hassan, Shafi Monjur Khan, again, okay, Rafi Khan. Okay, that's what so far I have received. Now, if your name is not here, Rafi Khan, after Rafi Khan, it is Mahmudul Kabir. Mahmudul
Yes,
Kabir,
sir.
have you sent it? Okay.
Yes, sir.
Okay, no problem. Someone was calling me and then cut. Okay, Mahmudul Kabir here. Now, are there anyone left?
So I have sent it, sir.
I have sent, sir.
Okay. Hello, who is that?
Sir, this is Dilshad.
Just 1 minute, please.
Sir.
What is that? Okay, what is your name? Tell me. Yeah, Mahabub Ali, I have received it. That's why I asked calling your name, but you are not responding. Okay, no problem. I received, but you have to come back. Okay, come back to the class because the class will be there. Okay. Hello. Anyone here that your name was not called? Anybody?
Yes, sir.
Sir.
Who?
Sir,
Yes,
my
sir.
name was not called.
What is your name? Hey, you don't know your name?
Sir, Ali Ahmed Rizvi.
Okay, good.
Sir,
Ali
Tawfiqul Islam.
Ahmed Rizvi. When you send Ali Ahmed Rizvi, when you send it, at the beginning or the last, at the end?
Sir, a minute back.
A minute back. Okay, let me check. Then your one will be coming. Yeah, Ahmed Rizvi. I got it. Next,
Sir.
Rifat
So
Ahmed.
Mohammed Zaman.
Yes, sir.
Okay, Rifat Ahmed, I got. Tawfiqul Islam, I received.
Yes, sir.
Sharif Ahmed,
Sir,
I received. And
Muammar
Muammar.
Zaman.
Muammar.
Yes, sir.
Muammar, I received Muammar. Okay, anyone else? No.
Can you hear me?
Hey, who?
Sir, this is Dilshad Jahan Shubho. Have you received it? I have sent the mail at 9:21.
921. Shubho.
Yes, sir.
No, I haven't received. Maybe it will come. Just now you send it then. Okay, your one not yet
Sir,
come.
can you hear me?
And any others?
Hello.
Hello, go ahead.
Sir, I have sent a mail using the name Farida Yasmin.
Yeah, Farida Yasmin, I was calling 1,000 times, but you don't respond. Yeah, I got it. Farida Yasmin, I got. Okay, Shubho, I think I haven't get it yet. You resend it. Shubho, you can hear me?
So this is, yes, sir, I can hear you. This is showing that this mail is sent. I don't know if you get it. I'm trying to resend it again.
Yeah, you have to pay money for that, right? Just send it again.
Okay, sir.
I didn't get it yet. Okay, once I think rest of you have already sent, so everybody is okay. Now let's come back to the class. We are going to, I'm going to show one thing first before going to the class. All of you can see the thing. Can you see the screen or not? Can you see the screen, all of you?
Yes, sir.
Yes, sir.
Some of you already dropped the
Yes, sir, I
class.
can see.
I'm going to take the snapshot, those who are dropped actually, because I will catch them. Simply, you cannot drop without us. You have to go for the class. What do you do? Sleeping at home now? Okay, just inform your friends to come back. Otherwise, I'll be catching them. Now let's come back to the point. In this is one important thing I'm going to show. Just after the exam, you drop out. What the thing is going on, I don't understand. If you're internet cut or you have problem, you should call me over the phone. Okay, now let's come back to the point. This is what the midterm exam cover page. Actually, I have already uploaded the BOX and I have sent it to you most probably, or in the BUX you can find it. You can see what you have to do. You download it and get the printout of it. I'm telling you again, download and print it, the hard copy. And after that, by hand, each of you write your name, ID number, course title, control system, course code 305. Okay. Hey. Okay, 305. Then semester, online summer 2020, and section 2. Once you're done, it is all you have to do today or tomorrow before the exam date, so that it is ready in front of you at the time of exam. Remember, this cover page is very important for me. Okay, now you can see underneath that here on the right, it is examiner signature and date. You don't touch it. Normally, some of the dark students still sign here and write the date here. Don't leave it empty. It is my place. And here, the examiner will write it. And here, number of pages. And you can see here, this is the top page. On top of this, you are going to answer on the white page how many pages you are going to use to answer the midterm, because there will be 2 questions. I have already sent you the sample, so you know that the 2 questions to answer, how many pages you required at the end, you have to write the number of pages here. Let's say this is the top page, or other than this, how many additional pages. Let's say you are going to use 5 pages. So you should write here number of pages. Over here by hand, you write 5, so that I can understand another 5 pages will be coming along with this cover page. And you should together, you have to prepare in a PDF file in one file and then send it to me. That's the way you have to do in the midterm exam time. That will convert, and that's why I'll give you a bit more time, not 5 minutes. It will be given more time so you can easily do it. And exam will be for 1 hour. And this is what you can see in the bottom. And you all know that Back University Student Honor Code already sent to you all. So this one, you have to sign here. Look at this. This is where you have to sign. And this is the date you have to write, your exam date. So exam date and signature should be done on the date at the exam. And this particular things, this thing, I'm talking about, okay. If we go for in one page, okay, now you can see better. these particulars, the name, student ID, and all these things, you have to fill up by hand before the exam starts. Means you get the printout today or tomorrow and do it, fill up these things. And during the exam day, you will just start writing. That's what you have to do. I'm telling you again, without this cover page, I'm not going to, I think I'll give you some penalty, remember. That's it. So everybody must, M-U-S-T, must attach this cover page. What to do after filling all these things? You will get a snapshot of these things after filling the thing, all these things. During the exam, after finishing the final exam, I mean the midterm exam, then you have to get the snapshot of this thing and snapshot for other page, and sequentially you have to arrange 1, 2, 3, 4, and then convert in the PDF, one PDF file, you have to send it to me. You know, this is also learning mechanism. The guy who can do it properly and nicely, of course, I'll have a good impression and it will reflect my marking on his script as well. So everybody should take care of this. Don't neglect it. Okay, and I see that some dark sign here in the signature of examiner. Instead of signing here, you sign here, your marks will be affected. Remember, this sort of dark thing cannot be accepted or cannot be tolerated as well. Hey, all of you understand? What happened? All silent?
Yes, sir.
Yeah, good.
Yes, sir.
Okay, that's all about the most important thing I need to tell you. Now, one thing I'm asking to do, hey, Aditya, can you open your, can you unmute your microphone? Yeah, Adnan,
Yes, sir.
unmute. Just I want to say, Adnan, can you unmute? Come
Yes,
on,
sir.
faster.
Yes, sir.
Okay, Rizvi. Okay, Rizvi, unmute it. Patwari. Patwari, can you?
Sir, my internet connection is not very
Good.
fast.
Now,
today, sir.
Patwari, I
I
think
have
then you can
problem.
close it. I want to see whose microphone is good. You can please unmute your microphone. I don't need to tell you. You do it. Those who think that your microphone will not giving any disturbance, noise, you please unmute your microphone, all of you. Those who are backdated, dumb, making problem, that sort of microphone, I should better mute it. Didar Islam, what about you? Yes, just now. Mamun, can you unmute?
Yes, sir.
Okay, can you unmute?
Yes, sir. I'm already done.
No, you who's making sound? Mamun, I think this is okay. There's still sound coming. Anyway, yeah, now it's gone. The guy who actually unmute, just please. Okay, some of you. I'm asking some of you, some of you. Sumaya Chua, can you unmute?
Yes, sir.
Okay, Sadia, can you? Sadia. Jahrat Tabassum,
Yes, sir.
unmute.
Yes, sir.
Okay, and then Tanvir Jahan, you don't have it. Jaharat, keep you unmute. All of you, those who I'm telling, all of you keep your microphone unmute. The reason is why, the reason is whenever I'm going to start the class and I'm going to ask you, hey, you understand? And then you say, yes, I cannot hear that sound because your microphone is unmute. That's why is a big problem coming there. I'm telling you, all of you can unmute unless if you think that it makes noise. Otherwise, you can unmute, all of you. So that it will be easy for everybody, as well as for me, to communicate properly when I'm start teaching at that time, asking question, you can answer, it's better. Okay, that's all about these things. And listen, yes, somebody music started. This sort of dark thing should be shut. Okay, now listen, I'm just telling you, do any of you have any question? I mean, any important question? Then if no, then I can start the class. If yes, then ask me. Regarding the midterm exam.
Cover page, sir.
Mm-hmm.
How can I get that cover page?
Oh, the cover page is already uploaded in the BUX. Can you, do you have access?
Yes, sir. I have.
Yeah, you can see. If you cannot find it or you cannot download, let me know by email or by calling me. The number is there, emergency number is there. So I think everybody can communicate me. Hey, what happened? Okay?
Yes, sir.
All right, no problem. Yes, bit faster.
The servo system practice sheet, I was having some problem in the last math.
Okay, in that case, we are going to discuss it after the class.
Okay, sir.
Those who are having like sort of problems.
What about 30 minutes extra time, sir?
A good point.
Sir,
30 minutes extra
we
time is,
need some, sir.
yeah, you need some time to copy from each other. Is it?
Sorry, sir.
Why you need extra time? Just 30 minutes enough. You need extra time for organizing all these things properly and send it to me by email. That is the main thing. I think half an hour is more than enough for you to do that. That's why the half an hour extra time should be given. So 1 hour is the exam time. Another half an hour is to organize everything properly. That what I told you. If you haven't signed, you sign. You check everything, how many pages you use, and a page number. Every page number, number 1, 2, 3, you have to write. You write your name, ID number. If possible, every page number, you write your name, ID number. Organize properly. Get the snap. Make the PDF and then organize in one PDF and then send it to me by email. It requires time. And that's why half an hour time will be given. Is it okay now?
Yes, sir.
Yeah. So still I see 2 ducks left. There are 32 students present in the, no, I'm just going to check it. Who are the dumb? Okay. I told you, ask your friend to come back, but I don't know where those 2 ducks are. One of them, I think, lost internet. He called me at my mobile and told me. I said, try to get it. Okay, no problem. I think I'll check it. Now, if you all...
Sir.
Yeah, any question? A bit faster.
Sir, do we have to scan the paper, scan our answers, or directly send you the JPG file?
That's half an hour time is enough time. If you have to convert into PDF and send it. But if you have problem that you cannot do it or something problem like that, then I think JPG file you can send it to me, no problem. But in that case, I suggest somebody can understand that your microphone is making sound, then you shut it down. Okay, now listen. If you think that you cannot do it, at least one thing you do. I think who asked me the question? Can you tell me the name?
Sir, Aditya.
Okay, Aditya, listen. Rest of you listen as well. If you cannot make the PDF and you cannot, at least you organize properly, like the cover page you have to fill up. That is, you can do it today and tomorrow, and rest of the thing on that spot you have to fill up, like a number of pages, how many you are going to do. And on the white page, you write your name, ID, and page number, and take the screenshot for each of the pages, including the cover page. And JPG file name, at least you can write the page number, page 1, 2, 3, 4, like that. And then if you cannot convert into PDF, at least you can combine them together into a zip file. And one zip file you have to send it to me. At least that will be easy for me to, you know, one email you pay, one page you send, another email, another page you send. If you do something like that, in the midterm, I will definitely give you a penalty. Okay, you're not a child. After 2 CT, 1 CT2, you must know by this time how to do the job. Okay, PDF, not necessarily you have to do, but you try your best. If you can do it, definitely I'll get a good impression about you. So what to do, Aditya, what to do? That's why you have to learn. Listen, you have to learn from
I think that
how to do it.
Yes, sir. I think that Jeep idea is better.
Jeep idea is fine also, no problem. If you cannot do the PDF, then you can just do the Jeep. We have discussed about different parameters, and based on the parameters today also you have answered. And those are the rise time, settling time, so rise time, peak overshoot. And also I have given some idea about settling time. What is the definition? According to the definition, we have, you know, that 2% settling time or 5% settling time. That's internationally we have explained in the last class. Now, in order to find the settling time, if you look carefully about this, that this is the peak. This is the peak of the city, and this is what happened from this down peak, up peak. What we can understand that the sine wave is dying out, slowly dying out exponentially. That means it is dying exponentially in this way. And if you go here from this as well, it will be from this lower side, lower peak, also giving you the impression that it is dying out exponentially. So exponentially dying out the sinusoidal. So what the blue curve is the envelope. So if you go with the upper envelope, this upper envelope, what is the equation for the upper envelope? The upper envelope equation will be the only the exponential decay, omega n t, zeta omega n t divided by root over 1 minus zeta square. The the exponential term, e to the power minus zeta omega n t term will be here, because the blue envelope is exponential curve, exponentially dying. So sine wave equation, the sine wave term will not be here. And similarly, the lower one, lower envelope will be exactly the same, but the equation will be 1 minus exponential minus zeta omega n t divided by root over 1 minus zeta square. So this is what we can see the two curves. Okay, I'm just going to redraw it. Okay, this is t. Okay, 1 minus zeta square is the equation for this lower envelope. So the upper envelope and lower envelope are having two equations. One is 1 plus 1 minus, and the only exponential term is there. Sinusoidal is absent because the blue curve, the blue envelope is just an exponential decay curve. It is having no sine wave. Sine wave is having the red curve, sine wave and exponential both. But we are not representing that. We are representing the only blue envelope. And if you go for the plus minus 2% thing, then the plus minus 2% part, if you consider, then it will be 1.02, right? 1.02. And the bottom part, if you go with that 1.02, so you get it like that. And this one is a minus 0.98. 0.98. So 1.02 and 0.98, and if you like last time, you have seen that, and it was something like this. If you go with this settling zone, last class I told you with the plus minus 2% settling zone, then we can say that again, what is the settling time coming here is this is the point where it is coming in. And you can say that somewhere like that, it can go with this settling zone TS, which is plus minus 2% settling time over here. If you say this point, and then we can say these are the points, we can say that 2%. Now, if the upper point, if you consider, then if you go for this point on the blue line, then it will be giving you what will be the value at this point. This value will be 1.02. So the blue curve, this point on the blue curve gives you 1.02. And from here, you can easily calculate. You get my point, what I mean? I'm going to write here, that is 0.1.02. And if you come from this calculation, then you are getting here exponential of minus zeta omega n t is equal to 0.2 into root over what 1 minus zeta square. That's what you're getting. Do you understand it?
Yes, sir.
Okay, good. So if you get this thing, then 1 minus zeta square, look at it, 1 minus zeta square root over 1 minus zeta square is approximately equal to 1, because zeta is 0.1. 0.1 square is 0.01. So 1 minus 0.01 is very, very small, which is approximately equal to 1. So we can say approximate, not equal, but it is approximately, because zeta in the underdamped case, I'm talking about zeta is be in some point value, fraction value. So this thing we can say is approximately equal to 1. And if it is approximately equal to 1 minus zeta square root over 1, then only 0.2 is there. If this is 2, then what will be the value of minus zeta omega n t? omega nt. Hey, this is TS actually. TS, we can say I'm writing here. This is all for this value is for t equal to TS. So I'm writing here TS. So I'm writing here TS. Okay, and that is for plus minus 2%. So you can understand it. Now, can anybody tell me what is this value? Do it and tell me.
Minus 1.61.
Wrong. Any other? Minus zeta omega and Ts equal to what? Exponential minus zeta omega and Ts equal to 0.2, because that is approximately 1. So it is 0.2 into 1 is 0.2.
Upper it will be 0.02, no, right?
Yes, that is 0.02. 0.0.
So then it will be
No,
3.91.
I'm sorry. No. I'm sorry. Somebody give me the answer. Maybe that is correct, but it is correct. You're right. It should be 0. Because 0.02. Absolutely
then
correct.
it will be answer
Yeah,
be
because 1 and 1,
3.91, sir.
1 and 1 minus 0.02 is subtraction is 0.02, right? Okay. What is that? It is what?
Minus 3.92. 3.91, sir.
3.91.
Minus 91.
Minus 3.91, right? Okay, minus 3.91. You can get it. So you can say that TS in that case is going to be what? Approximately, we can say it's approximately, if you say that. The 3.9 we can approximately, we can just have a rigid number, integer number we can put, and then we can say it's a zeta of omega n. So the TS plus minus 2% is giving you 4 divided by approximately 3.91, or just 4 divided by zeta omega n. Most of the books you can see write it 4 divided by zeta omega n, because some sort of approximation is done here. That's why you can say approximately 4. No problem. So this is what the zeta value for plus minus 2%. And if you go for the same thing for the bottom one, then this one will be what? This one will be 0. What is the value here? Can you tell me what is this value? This is equal to what?
So 0.98.
Right.
0.98.
That's the same answer you get, 0.98. If it's 0.98, and if you can simplify the whole thing, you will get this thing, right? Same thing. Yes or no?
Yes, sir.
Yes, sir.
Yes,
Same
sir.
result.
So same thing you get. So the same answer you get. Either you consider the upper envelope or you consider the lower envelope. All are same. Hey, 26. Okay, I understand. People gone back home. A lot of waiting for what? Or having dinner. If you have not dinner and you're hungry, you can go back and come back after dinner. No problem. Now listen, you shut your mouthpiece. Why you talking to girlfriends? Why you shut the microphone? I was just getting the feedback from you. That's the reason why I told you to keep it on. Okay, all of you understand or any question so far? Hey, this is the reason why I told you, please unmute the microphone.
No, sir, no question.
Yeah, please keep microphone unmute so that you can instantly answer me. Understood?
Yes, sir.
Yes, sir.
Excellent.
Yes, sir.
Now, all of you, please go faster and do it for 5% and tell me what is the TS for 5% equal to. It's very straightforward if you understand it. And please keep your microphone unmute. Then it will be easy for you to call me, talk to me. Anybody got the answer? Tell me.
So 3 divided by zeta omega.
Excellent. So approximately it will be TS. I'm writing here with the green pen. TS plus minus 5% will be approximately 3 over zeta omega n. Good. This will be the answer, 3 over zeta omega n. Okay. That is your answer. Plus minus 5% will be 3 over zeta omega n. Now, how it is possible? Because this one is no more 1.4. This is 1.05. 1.05 and this is 0.95. 0.95, then this is 0.5. 0.5 means this is 5. And this will be no more 3. It will be what? Minus, is it 2.9 or something like that?
2.995.
2.995, approximately 3. So it is not 4, it is approximately 3. And that's why it is 5% gives you the 3 over, this is 3 over zeta omega n. So if it is 3 over zeta omega, that one is a 4 over zeta omega n, and this is 3 over zeta omega n. And last class I told you, and you also know that 5%, 2% is greater than 5%, and it is fact. 4 is greater than 3, so it is proved as well. So that's a very simple. These are two equations we have to remember. I think everybody understood. Now I'm just going to write here settling time. Settling time. In today's question, I didn't put the settling time there because I know that you didn't learn it. So we can conclude TS plus minus 2% settling time is approximately equal to 4 over zeta omega n, and TS plus minus 5% settling time approximately equal to 3 by zeta omega n. So these two equations you have to remember for plus minus 2%, and this is for plus minus 5%. Now there's some practice problem I have given in the practice sheet, and you can see the settling time is, there are some problems. You need to know the settling time or utilize the settling time. So you please now can easily solve those problems easily. And I think you should not have any problem, but if you still have problem, we will discuss it. If required, then I'll go through some sort of consultation time, no problem. You can discuss among yourself also, no problem. I think at the end of this class, those who are having some problem, we can discuss it. Now, this is all what about the settling time I should discuss. Now we are going to jump to the new topic, settling time part done. So second order time response is completed. Our new topic will be now steady state error. That is what our next topic, and that is the new topic we are going to do. This settling time in the last class is continuation from the last class. As you know that one of the parameters were left. And today we are going to talk about the steady state, okay, steady state error. Steady state error plays a very important role. All of you should understand. If a machine is producing a nut bolt from the CNC machine, and you have designed a control algorithm and sent the data to the machine, and the machine produce a lot of nut bolts, but if there is an error, then all continuously produce 1 million nut bolt, all will be rejected because a continuous error is there at the output. So error in the output is a serious problem in engineering era or in the field of engineering. As an engineer, you cannot allow that. So there should be error free. So we have to study that steady state error means what. And you can easily understand the steady state error thing. You look at it. I'm just going to draw a time response curve, as you already know that. So if this is unit step input, and this is the thing coming, ting, 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 and going like this, and I'm meeting here. But as I said that there are some cutting point here, so that we can say that this is the cutting point here. So what does it mean? It means t tends to infinity here. And this is the transient time, transient, and this is the steady state. Steady state and transient period. So transient period is first a shorter period, and steady state a longer infinity you can go. Now, we have already studied last class this part, the transient part. All the parameters, rise time, peak time, ting time, all these things we have studied. And today settling time also done. Now, steady state error on the right hand side, there's a t tends to infinity side. That is steady state. And if you go, then you can see here that this part is your RT. This is RT equal to 1, which is RT equal to 1. You know that RT equal to 1 is step input. And this gut is what? The blue, the red one is a city. So city is coming, yeah, city. So city is coming here, and that RT is on the top. So the difference, you can see the error there, a little bit error is there present, and this is your error ET. So ET will be what then? ET will be nothing but RT minus CT. You can just think like that. Continuously, the difference is coming at the output. And if for t tends to infinity, if it is coming, the thing, then we can say that that is the error we call steady state error. T tends to infinity, this error is giving you the steady state error. The continuously the error is coming, it's a steady, it's coming. How to define? Limit t tends to infinity, okay, ET, that is ET is the error, which is the difference between RT and CT, that is the error. So the steady state error, this is your steady state error definition. We can write that ET equal to limit t tends to infinity ET. Now, according to the final value theorem in Laplace transformation, final value theorem said what? According to final value theorem, FTV, final value theorem, I think in EEE 243 signal systems you have studied, Laplace table said that the final value theorem is giving you the limit t tends to infinity f of t, function of t. If you go take the Laplace transformation, you will get limit s tends to 0. Okay, s tends to 0, now SFS, if the initial conditions are 0. So this is what the final value theorem said. The time domain, this is the time domain, this is the frequency domain. So the time domain to frequency domain will be like that. So if this is the scenario, and then we can say that if you apply the FTV here, then what will be this equivalence comes? That is just will be in terms of frequency domain. It gives you s tends to 0, and it will be SES. Try to get it. Yes. So your steady state error definition in frequency domain through the final value theorem is coming here as ES equal to limit s tends to 0 SES. So this is our definition in time domain as well as frequency domain, and that one you get through the FVT, final value theorem. So what was that? We have just left behind the steady state error is equal to limit in the frequency domain. We got s tends to 0 SES. That is what we got. I think you all can remember. This is the one we got, like this one. Steady state error is equal to this. Now, let's go with this gut. If you look back our canonical form, which is like this, the plant is here. And if we consider for the sake of simplicity that is a unity feedback, then minus, this is plus, this is your G plant, this is your C, this is your R input, and this must be C in that case because it is unity feedback. H is 1, so unity feedback, and then if it is something like that, then your C is straight away coming as a feedback. If it is coming as a feedback, hey, listen, what will be, this is the E, this is the error, this is your error, and error will be R minus C. That's the reason why we are going to take the E as like that. Now, you remember we have studied the error ratio last time from the canonical form. Error ratio, you find the error ratio. What was the error ratio? Remember, E by, hey, what?
1 by
No, E by what? Come on, Duck. E by what?
E by R.
That's the first thing. Then 1 by 1, dumb. First of all, you should tell me what is this. Okay, now you tell me what? 1 divided by what? You're right. 1 divided by what? Tell me, you remember.
1 plus GH.
Excellent. But what is H here?
1.
1. So we don't need to put H here. Simply H equal to 1. So let it be 1 by 1 plus G. Should be fine. I'm not writing S because you have to understand that all capital letter means this is in frequency domain. So in this case, if you come up with this, hey, what is E equal to? Equal to what? Equal to R, you cross multiply, and this comes here, this goes here as a G. Is it okay? cross multiply. R is going there as a signal. It is the thing. Now, if it is something like that, now you look at it. This E, I'm sorry. Okay, this E, you are going to take it here. If you substitute the E here, then what are we get from here as steady state error? ESS is coming here as what? ESS is coming here as limit S tends to 0. And if you substitute that E over there, then you are getting here as a SRS. We can write S now, so this S coming there, so you can understand that S is a function for each of them. I think you all know that this is S like that. So capital letters of frequency domain, 1 plus GH, like that. So your steady state error equation is coming here like this, right? Which is a function of two things. One is this signal, and another one is this system. S is an operator. Don't worry about this S. S is operator. Only the R and G. So R is the input signal and G is the plant transfer function. These are the two things we are getting here. So we can say this steady state error is a function of R and G. Got it?
Yes, sir.
Okay, good. Rest of your microphone is off, right? Hey, you're busy with girlfriend or boyfriend, something like that. Why your microphone is off? All of you should respond to my call, are sleeping or watching movie or gone back home somewhere else, and just keeping me busy, right? And come back at the end and shut it down. Listen carefully. Please try to participate. Okay, now if this is the scenario, we can have the steady state error, which is depending on two things. One is the input R, another one is the plant transfer function G. These two things. Now we are going to do, if you have no question up to this, then we are going to do the steady state error analysis for different, I think better you mute. Some of you, big problem. Some of you, I think those who are confirmed that no noise will come, you can open the, keep the unmute or just mute it. Okay, now let's come back to the point. We are going to find the steady state error for a different input and different plant transfer function.
Sir, I have a question, sir.
Yes, sir, good.
So what if it is not a unity feedback system?
Then our steady state error, which one we are going to get here, servo system we are getting is a unity feedback system. We are going to consider that system, number one. And then we cannot have this relationship, right?
Yes, sir.
Okay, I'm going to consider about the servo system for a second order system, servo system, which we have considered. Which one was G was what? Remember, K over SJS plus. Can you remember this? Why you forgot it? Who asked me the question? You forgot the servo system was this, and unity feedback. You go back to the servo system. Finally, we got what canonical form. That one was having a unity feedback or not?
Yes, sir.
Right.
Unity feedback system.
Well, we are going to consider the second order servo system as the system here for analyzing all these things. So we are keeping it as it is. Now listen, come back to the point. Now we are going to find the steady state error for different input. I'm telling you what, if you say if, there a lot of if can be happened. First if is what? First if is a big issue. What is that? You know that the thing, first if is God made the world, and everything in the world, every system in the world are, try to remember it, are non-linear system. This is the main problem. But all the theory we are talking about All these things all are linear system. This is what some are inherent nonlinear. You will see in future, or you can see also here in your life, like a resistor, and then capacitor, inductor, nonlinear, like sort of you have to linearize the nonlinear system through the linearization method. So we are not going to do those things since all systems are nonlinear. So for the sake of simplicity, we are considering the linear system, and we can straight away apply the theory on it. So this is one assumption, first assumption we are considering in our practice. So if you say if, then a lot of if can be happened. Okay, we are going to see those things later. Now we are going to see what first. Let us see first. Okay, now for what we are going to do here, you please try to get my point. We are going to find the steady state error for different input and different plant. Different plant means type of system and different input. Among, you can see a lot of inputs are there. In EEE 243, you have studied what? Step input, ramp input, parabolic input, impulse input, and then some higher input. A lot of type of inputs are there. And there are different type of the system also, G. Hey, can anybody tell me, I told you earlier, servo system is a type what? What type of system? Type 0, 1, 2, 3, 4.
Type 1.
Type 1 system.
1.
Excellent. So we are going to consider different type of system means it can be type 0, it can be type 1, it can be type 2, it can be type 3, it can be type 4, it can be type 5, like different type. So we are going to consider different type of system here. So instead of considering 0 to infinity type a lot, we are going to take, remember, no question here. Sir, why 3? I'm going to take 3 type of input and 3 type of system. 3 input, 3 inputs and 3 types of system. That's it. We are going to consider. You can consider 0 to infinity type, doesn't matter. But we are going to consider for simplicity, and then from there you can easily understand what will happen for the other types and what will happen on the other input. So these are the things. Now what input and what type we are going to consider, that one I'm going to show you here. Okay, I'm going to write it. You know that types we are going to consider are as a 3 types. One is we are going to consider step input, unit step input, and you know that unit step input is just this one, and this is r t equal to 1. You already know that. So rs will be what? Hey, r t equal to 1. If r t equal to 1, rs will be what? Rs will be
1 by s.
1 by s. You all know that. And then number 2 is a ramp input, unit ramp. If you go for, I'm not telling you because you know that from EEE 243 signal systems you have studied. So this is ramp input, and the ramp input is, what is the equation? R t equal to what? Adam, what happened?
T.
R t equal to t, good.
R equal to T.
Then rs will be what?
1 by s square.
Excellent, 1 by s square. And then third one we are going to consider is the ramp input, unit ramp, unit parabolic input. Okay, go for unit parabolic input is going to like that. Is a t versus t, and this rt unit parabolic, then it will be t versus rt equal to t square by 2. Unit means is to make it 1 when you go for rs. Now if you go for rs here, it gives you 1 by s cube here. That's it. So this is the way we can go up to 3 input we are going to consider. Likewise, we are going to consider 3 types of system also, G. So 3 types of system if you want to consider, then you have to find a generalized equation for a system. In general, we can say that G is equal to, we can assume like this. Let's say K is a constant. We can say 1 plus T1s. The zeros, these are the zeros on the top, T2s dot 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 dot, and there are, let's say, TMS, there are M0 there, and same thing like there on the bottom as well. We can say s to the power n, the poles, s to the power n pole, and this is the pole at s equal to 0. Hey, remember different location of poles on the S plane. So S to the power n, this is located S to the power n. Okay, I'm just going to, you are all thinking, what is this duck? This is n. Okay, S to the power n, I'm writing the n and the red pen because this n is a very significant thing. So S to the n is a pole which is located at the center. Okay, you'll understand it later why I'm telling you this. S1 prime S, this one can be 1 S2, T2 prime S, this one can be 1 plus T n prime S. So there are n number of poles, so that n is more than or equal to m, like that way you can think. So on the top is a 0, you know that I told you earlier as well. These are the zeros and these are the poles, like on the bottom is the poles. So that's okay, you should know that. But you see, I have specifically I have put these things with the red pen. The reason is this n actually is indicating, in fact, the type of the system. Type of the system. This is in general, we can say. Now, n value can be 0, 1, 2, 3, dot, 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 up to infinity. It can be. So if n value is 0, then it is a type 0 system. If n value is 1, it is type 1 system. N value is 2, then it is type 2 system. This is the way actually the n value is indicated. Now, in our case, the servo system G was K over S into JS plus B, right? And you said, hey, remember, some of you said just now today, it is a type what? Servo system?
1.
1. And that is 1 is here. S to the power 1 is here.
Type 1.
Yeah. This one, you can write it like this, K by B, and then you can write here, what? 1 plus. You understand it, right? In that form, I'm talking in that form. You want to write in that form, you can write it 1 plus J by BS. J by BS. J by BS means, right? You get my point, what I mean? J by B means it is your format is like that format. This is the format we are going to follow. This is that format. So there is no 0, but there are 2 poles in the servo system. One is at S equal to 0, another one will be at the other one, which is minus B by 2, B by J. So these 2 are the 2 poles, so this and this, but all others are not present, only the K is present. That's the way this servo can be defined, and it is a type 1 system. This is what? This is a general equation I'm talking about, and this is for a particular servo system we are going to answer. Now, for our simplicity, we are going to consider, all of you can see, we are going to consider the type 0 system, type 1 system, type 2 system. Only these 3 type of system we are going to consider, and 3 type of input we are going to consider. So 3 input, 3 type we are going to consider for our steady state error analysis. Anybody got any question, or we are jumping to the next point? No question. Now, what we are going to find? We are going to find the steady state error for different type of system. So we can consider first type for a step input first, and then we'll find it. So let's say, first of all, we are going to, our target is to find a steady state error equal to what? That for, let us, for first one, we can go for unit step. For unit step input, we are going to find this thing. Hey, you told me just now, unit step case, RS is equal to 1 by S. If this is the scenario, what is the steady state error will be? If RS is the, okay, I'm writing here, steady state error equation. Remember, what will be the steady state error? What is the steady state error equation? Hey, look at it. This is the steady state
1
error
over
equation.
1 plus G.
Where's that? The previous one, right? Yeah. No, not that one. Steady state error equation is this one. Oh, I think I have written there also. Yeah, this one. you look at this is the steady state error. Steady state error identification is that limit s tends to 0, SES. SES. And if you put SES, then steady state coming here like this. So this is our final steady state error we are getting. So what is that? Limit s tends to 0, as you said, SRS divided by 1 plus GS. So we are writing it here that steady state error is coming here as limit s tends to 0, SRS divided by 1 plus GS. Now, if you put the value limit s tends to 0 and SRS, RS is what? RS is 1 by S. So SRS for step input and 1 plus GS. So SS cancel out. Now you are getting it here like this. 1 divided by 1 plus, if you know the calculus, you might know that this can be written a limit s tends to 0 GS. Okay, you can take the limit like this. So 1 by 1 plus ding dang ding means you can say equal to 1 divided by 1 plus, this one can be represented as a KA. Sorry, K as a K. Okay, K, you can write okay, position error. What is a position is P. So KP you can define this one as this thing where it means where, I'm just writing here where KP is you understand is meaning is the limit s tends to 0 limit s tends to 0 GS, and that is known as static position error constant. This is called static position error constant. Okay, this is what the KP. So this is what we are getting the steady state error equation so far. Now all what we need to find the KP, and you substitute the KP here and you get the value of ESS. That's it. Work is completed. Now first thing with this thing we are going to find for number 1, we can say that for type 0 system, as I said, steady state error for different input. So I am telling first we am taking the unit step input. For unit step input, I'm going to consider all the three types of system. Then next I'm going to consider number 2 is a unit ramp input. Which is RT equal to T, so that R is equal to 1 by S square. And again I have to find the ESS here, and I have to find again for type 0, for type 0, for type 1, for type 1, okay, type 1, then for type 2, like sort of way we are going to. Then again next page we'll go for parabolic input. Like that way 3 type of input we are going to consider for 3 type of system. So if we go for type 0 system, then what will be the KP for type 0 system we should get? So for type 0 system, the KP will be coming here. What? Let us see. The KP will be coming here. KP definition is KP limit s tends to 0. S tends to 0. GS. A GS will be what? GS will be for type 0. Remember, type 0 What is GS? You look at it. Type 0, GS will be what? S to the power what? N value will be what? Capital N?
0.
0.
If it's N is 0, then what will be the equation coming here? K into 1 plus T1S, 1 plus T1. Bottom side is coming, S to the power 0 is cancelled, 1 plus T1S, 2S like that. So if it is type 0 system, the GS is going to be, this GS is going to be what? This, okay, if it is something like that, then GS will be coming here like K into, as a K is coming into 1 plus T1S and dot dot dot. And on the bottom, S to the power 0 is gone, 1. So it is 1 plus T1 prime S and dot 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 like this. And if I ask you what will be the value if S equal to 0, you substitute, what are you getting here? You're getting a K. Do you understand it now? Hey ducks,
sir.
all of you understand?
Yes.
No.
Yes, sir.
Okay, good. If you understand, then tell me, in this case, what is the steady state error ESS should be for type 0 system? What will be the steady state? I'm going to write the steady state error with the green pen so that everybody can get it. Hey, tell me, what's that?
1 over
1
K.
divided by 1 plus K.
Good, excellent. Steady state error will be equal to 1 over 1 plus K. That's it. Your steady state error you are getting for type 0 system. So now if I ask you, every children can tell me very, very easily, if I consider type 1 system, hey, what will be the KP? And you tell me the KP will be what? Limit S tends to 0 and KP will be what? KP will be K into 1 plus TS, T1S, dot 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 dot, and this one will be S to the power for type 1. So type 1 means there is a S here coming, and there 1 plus T1S, T1 prime S, right? T1 prime S and dot 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 coming. So what will be the answer coming there?
Sir, as S equal to 0, so there will be infinity.
Absolutely great answer. Beautiful. Everybody should understand this S, if you put 0, then K divided by 0, all are 1, 1, 1. So K something divided by 0 is infinity. So this is infinity. Everybody, anybody got question or okay? Hey,
Okay,
there
sir.
are,
Okay.
I think most of your microphone is not disturbing. Only 2 or 3 rotten apple make the sound. Everybody shut it off because of those. Please, you can answer, please. Okay, now let's come back to the point. ESS will be then what? ESS will be, anybody, I'm sorry, somebody told me the answer. What is that?
0, sir.
Absolutely good, excellent. Because if K is infinity, KP, you put KP is, if you put KP equal to infinity here, 1 divided by 1 plus infinity is 0. Everybody should know that. I don't need to explain that. I think now, according to that, if you go for type 1, type 2, it is very simple. Now, your KP will be what? KP will be
So
limit.
like type 1, sir.
No, you can see here.
Same answer, sir.
Oh, like type 1. Yeah, that's right. Like type 1. Because it is the same thing happened. Excellent. Good. So you understand it better. Okay. Now you can get for, this is type 2 means S square here, but it is same like type 1. You are right. Absolutely correct. And dot dot dot. What will be this value?
So infinity, sir.
Infinity, and steady state error
ESS
will be
0.
0. Good. So you all understand it. Likewise, if you go for type 3, type 4, it will be similar, right? Yes or no?
Yes, sir.
Yes,
Only
sir.
the value
Yes,
will
sir.
be changed.
Yeah, you all understand it, I hope. Now, exactly the same way, you please write it down by yourself and find it for the ramp input, unit ramp input by yourself. What will be the equation for ESS? Like I have found the equation for ESS in this case was this, where P is the static position error coefficient, which is like this. So you have to find what will be that one, and then you can go. If you understand, I hope that you can also do it. Can you please go ahead and find it by yourself? I'm going to ask you question, giving you 2 minutes time, bit faster. Go fast. Yes, anybody could find the solution. ESS will be what? Go ahead.
So 1 divided by limit s is to 0 SGS.
Good. So it will be, okay, I'm just going to do, and you tell me with me, then should be fine. It is limit s tends to 0, just s tends to 0, and it will be what, s into rs. Rs is 1 by s square, and this is coming here 1 plus gh. So you are getting here, like the top is a 1, and this is actually limit s tends to 0 s plus limit s tends to 0. Just first time, that's what I'm going to show you. Gs you are getting. So you are going to write here 1 divided by this part is gone to 0. So you are going to write here limit s tends to 0 SGS, as you said, SGS. Good. And this part on the top, 1, and SGS, since S means, last time GS we called KP, and now SGS, we are going to call this one, S is a DDT actually, we can think like that. So it's a position, then DDT of position is a velocity. So we can say this is velocity, SGS means is a velocity coefficient. So we can write here as a kv, we can write instead of kp, because s means is a ddt, and that comes into the frequency domain as a s operator. So we can write here instead of v, p, we can say v, velocity error constant. So this called, this name kv is called as a we can write here this kp, where kv is as you said, that limit s tends to 0, sgs, and which is called velocity, static velocity okay, I'm rewriting it here, static velocity error constant. This is called static velocity error constant. So for type 0 system, if you go for finding the kv value, and the kv value will be equal to, you all can understand, at the limit s tends to 0, and if you put the value of kv, it is going to be what? Kv is going to be k in,
0, sir.
yeah, how you got it? 1 plus 1s, yeah, it will be 0 maybe, okay. How
So
you get
there will
0?
be a
Because type 0
S1 in the
system.
front, sir.
And the S is
There
coming
will
there, right? There's
be
a
a
S there,
S.
right?
Yes.
SGS. So S will be there, and it is 1 plus T1 prime S. Good. And in that case, this S actually, this S is making it 0, because limit S tends to 0, and that is SY coming here, because it's a G, it is SGS, remember, it is SGS, not, this is SGS. So S is coming there. So S is making 0. So if it is 0, then what is your steady state error coming here? Can you tell me?
So infinite.
Yeah, 1 by 0 is infinite straight away, because 1 by 0 is infinity. So that's the way you can find this thing. And similarly, if you go for type 1 system, if you go for type 1, then what will be the type 1 system gives you? Type 1 system, kv will be what? Kv will be, did you find it? Limit s tends to 0.
Then maybe 1. Sorry,
Or
sir.
maybe it should
Maybe
be, okay, S,
KV হবে, sir.
yeah, it is S into 1 plus T1S dot dot dot, right? That's what you are thinking. Dot dot dot. Oops, okay, and bottom side is coming S to the type 1 means S into 1
S to the
plus
power 1.
S to the power 1, right? Dot 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 dot. Now this S's cancel out actually on the top S, and the bottom S is cancel out. You cancel out, then there's no S. Now if you put S equal to 0, straight away you're getting the value what?
K, sir.
Exactly,
It will be
you
K,
get a
sir.
K value. So your steady state error will be what? What will be steady state error? ESS.
So 1 by K.
Yes, ESS is 1 by kv, kv is k, so 1 by k. So your final answer is this one is for this type 0. This is type 1 system. Now for type 2 system, for type 2, what is the kv? Now you can easily find it by yourself. The kv will be what? Now you can easily tell me the answer. S to 0.
Sir, infinity, sir.
Infinity, because it is coming here as a sk 1 plus t1s dot dot dot, and this one will be type 2 means as s square, and it is the standard equation we are going to put dot dot dot. Now you go with the cutting thing here, s is cancel out, it is coming here s to the power 1. So what will be the answer coming here as a kv value?
Sir, infinity, sir.
Because s to the 1, s is infinity, you get the infinity. You get the infinity, then you are getting ESS is going to be what? 1 by infinity is
0.
0. This is what you are getting, the 0. Now, for type, hi, sleeping guts, now you can, Fairoz binte Farooq. Fairoz, are you sleeping?
No.
Okay, can you tell me if it is a type 3 system, Huh? Farouk, Fairuz, can you tell me if it's a KV3 system, KV will be what for type 3? It will be what? S square will be what? Here, S square will be. Can you see? If it's type 3 system, it will be S cube, right?
Yes, sir.
Fairuz is there. Fairuz, can you? Oh, Fairuz gone. Please, anybody got question can ask me. I think maybe she got some problem with the internet or. Okay, who can voluntarily tell me the answer? Anyone?
The acceleration.
No, I'm not asking you. You can go for. Who are you? Jaharat.
Patwari, sir.
Patwari. Okay, Patwari. I think someone else should come forward. Anybody? What will be the answer for type 3? Anyone else other than Patwari?
So KV equals to infinity.
Infinity.
Right.
Same as type 2.
Sir, same
Infinity.
as type 2.
Exactly. And it will be steady state error will be
0.
0.
0. You got it? Because in this case, it's a limit s tends to 0. And it will be same s into k into 1 plus t1s, and on the bottom will be s cube, 1 plus t1 prime s. So s and s cube cancel out, s square is there. If s square is there and s is infinity, you put, then the whole thing will become, if s equal to 0, you put, the whole thing will become infinity. If s square 0 means it is infinity. So if it is infinity, it's a 0. So what will be the thing now? Anyone else? Please, I'm telling you, some other people like Ahmed Rizvi, then Tawfiq Islam, Mamun, Mahabub Sifat, all of you are here. Any of you can tell me if this is not 3, if it is a type 4 system, then what will be the answer? Anyone?
Same, sir.
Same.
Zero, same, sir.
Same, sir. Beautiful. That is the answer. It is same. So if it is same, then what we can say, if it is 5, also same. It is 6. What does it mean? It means higher type.
To n.
Yeah, if the type is high, with the high, if it is more and more the type, then the steady state error is going down, 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 0, towards 0. That is what happened over here. We can understand. Now that is done. Now we are going to go for, this is number 2. We have seen what? We have seen number 2 for, this number 2 for unit ramp. We have seen unit ramp. Now our last.
Sorry, sir, my power was cut down.
No, it's all right, no problem. I understand. I told them as well that Fairuz may got some problem in the internet. Now, Fairuz, try to get my point. We are going to go for the next one. Next one is, this is 2 for ramp input. Now we are going to go for, what is the next input? Anybody? I told you 3 input. Parabolic, unit parabolic. I told 3 input. One is a step input. Unit step we have done. You can see we have done the unit step. Right, we have found all the steady state. Hey, the green one, steady state error, green one are the steady state error. We found all these 3 green for unit step, for type 0 system, for type 1 system, type 2 system. That's why I told you, for different input, different type, we are going to find different type, we're going to find the steady state error. So for step, unit step, we found for different type, the steady state error is this. And you can see here also, if it is 3, type 3, some of you told me earlier, steady state error will be 0 here. If it is type 4, again, if you do the thing, you get steady state also 0 here, right?
Yes, sir.
Yes, sir.
So what does it mean? In unit step, also we saw the more the type, 3, 4, 5, 6, 7, 8, 9, 10, the more the type, the higher the type, the steady state error is going down to 0. So this is what we saw here as well. The higher the type, 4, 5, 6, all the time we're going to say that steady state error going down to 0. So now our next input, the last input we are going to consider is the unit ramp, unit parabolic input, as one of your friend told. I think he is very much online with me. Good. Now look at it. Number 3 is unit for unit parabolic input. parabolic. I have written already the unit parabolic input. Can you tell me what is the equation for unit parabolic input?
1 by s cube.
1 by s cube, right? That RT was what?
T square by 2.
Beautiful. T square by 2. Good. T square by 2. And that gives you, as you said, RS is giving you 1 by s cube. This is what the unit parabolic, and that's the last one we are going to study today and then finish after solving one problem and go back home. Now, you are already at home. Now, listen, this is what we can have. Now, you can easily understand from here, by definition, the steady state error equal to what? Steady state error equation, we have already found that this is equal to, what is the formula we got just now with RS divided by 1 plus GS, as you all know that. Now, can you tell me, one of you, what will be the final equation we are going to get from here?
So 1 divided by limit s is to 0 s square plus limit s is to 0 s square gs.
S square gs. So, and that one 0, 0 cancel out. So what we're getting here, 1 divided by, ultimately, obviously I'm not going to do it. You can easily understand. 1 divided by limit s tends to 0. Hey, s tends to 0, then?
S square.
Right. S tends to 0, s square, what?
GS.
Beautiful. S square GS. This is what we can do it exactly the same way we have done early. So everybody should understand it. Okay. Now, this can be written here as 1 divided by this full gut can call about K something. Can you tell, anybody can tell me something means what? S square means, S square G means d square by dt square G. That means in frequency.
Acceleration.
Acceleration, right. So what is the first, what is K what?
Ka.
Right,
Ka.
Ka. Good, Ka. So we can write here that 1 divided by Ka. That's it. So we can say this is the Ka. All right. So if this is the Ka, I think all of you understand it, right? All silent. What happened?
Yes, sir.
Okay, good.
Yes, sir.
Where Ka is static acceleration, what? Error constant. This is called static acceleration error constant, like the velocity, like that way it is the one we can say. Now we are going for one by one. The slide for type 0 system. Type 0 system we'll find from here what is the steady state, what is the Kp, we are going to find what is the Ka, we can find from here, or we can say K is a limit s tends to 0. This is the formula, Ka equal to this guy, right? This is what Ka is equal to. Actually, I didn't write it, but you can understand it. It is the limit s tends to 0 and s square gs. This is Ka. So Ka is s square gs. So limit, you have to write here s square K 1 plus T1s, the standard equation. And this is, what is the type 0 system means? It is s to the power 0, so it is 1 T1 prime s and dot 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 equal to what? Hey, I'm asking one person. Please Patwari and other people, those who are answering, you're just silent. If anybody else can give the answer other than these guys. I'm just asking. Rabbul Khan, if you can give me the answer. Rabbul Khan, what will be the value here? Now, if you're Rabbul Khan, I'm talking the option, anybody. Rafi Khan, Hasibul Hassan, anybody? No, you can tell me the answer. Dilshad Jahan Shubha. Yeah, what is that?
0.
Good.
Zero.
Absolutely correct. Because the s value, if you put s equal to 0 here, straight away the thing will be 0. So your 0 means the steady state error. Yes, can you tell me what is the steady state error in that case? What will be that? Steady state error will be 1 by Ka. K is 0. What will be the answer?
Infinity.
Infinity. That's what we can get from here. is infinity. Good. So if you go for number B is for type 1 system. But if you go for type 1 system here, so I think anybody can now answer if a Ka will be what? K will be limit s tends to 0. And what will be this guard coming then? It will be s square K. Anybody can tell me what will be the answer? Open question.
So 0.
0
And
as well.
infinity,
Because,
sir.
yes,
ESS
sir.
will be infinity.
Because 1 plus
0.
T, yes, good. T1 prime S and dot, dot, dot. 0, because S square cancel out, still a S on the top. And that S makes it 0. So your steady state error will be now also what? Hey, what is this?
Infinity, sir.
Infinity, right. Infinity, because 1 by 0 is infinity. Okay, fine. Now number C. If you go for C, then it is for type 2. As our type 2, we are getting here, the Ka will be what in this case? Can you tell me the answer?
Okay.
K. Good.
Okay.
Yes, sir. You are right. Limit s tends to 0, and this is s square K 1 plus T1 S dot, dot, dot. And this is S square also. And this is 1 plus T1 prime S dot, dot, dot. Now, this S square cancel out. So K is there because all S equal to 0. So what will be ESS?
1 by
1 by K.
Good. Now you're all on track. So your SS is 1 by K. So this is what we can say. Now, can you tell me if I say it is type 3 system, then what will happen? What is Ka should be?
Infinity.
Ka should be infinity. Good. Because it is S square limit S tends to 0. This is S square K 1 plus T1 S dot, dot, dot. And this will be S cube.
Sir.
Yes, sir.
K is equal to 0.
Right. And this is dot, dot, dot. So it is S square. S is coming underneath. S is underneath. What will be the K?
Infinity, sir.
Infinity. And then your steady state error will be SS 1 by
0.
infinity is 0. So, okay, what I am just telling you, all of you, if it is 4, if it is type 4, then what will be the
Same, sir.
same, sir? It will be also 0. So 4, 5, 6, 7, 8, whatever the higher, it all will be steady state error will be 0, 0, 0. Everybody should understand. Really, you understood?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Now, have you copied? No.
Yes, sir.
I am going to ask you questions.
Yes, sir.
Now, you give me the answer after finding the answer from your copy, that what you have copied. Look at it. This is the final conclusion we are going to go for. I'm going to plot it like this. Okay. Okay. Tell me what will be the answer here. Okay. This is the box I have drawn. Now,
We can't see.
Sir, we cannot see.
oh, I'm sorry. What's the problem? Can see now?
Yes, sir.
Yes, sir.
Okay. Now, what happened? These things I'm writing here as a type. Okay. This is the input, and this is the type. Type is what? Type 0, type 1, type 2 system. And input is step input 1 by S. This is, okay, I'm writing here step. This is ramp. This is parabolic. Okay. Now, you have to tell me what the steady state error. I think you really copied or not, just sleeping and doing nothing. Rahtul Jannat, are you here?
Yes,
or
sir.
busy? Okay.
Yes, sir.
So Rahtul, can you tell me what is here? What will be this steady state error?
Sir, for ramp parabolic, type 1 equal, type 0 is infinity, type 1 is infinity, type 2 is 1 by K.
Now, but my question here, this one is what type?
Sir, type 1.
And what is the input?
Infinity.
Hey, input I'm talking about. This is the input line and this is the type. So you said this is type 1. And I said, what is the input here? What is this input? Oh, you cannot see. Can you see? What is the input?
Sir, RAM.
Ramp. So this box means if we apply ramp input to a type 1 system, what will be the steady state error? Have you copied? Then tell me. Ramp input type 1 system. What is the steady state error? 1/k. Please, no boyfriend. Let her answer. And she doesn't like any boyfriend here. Hey, you understand it? What is the
K.
answer? K. Is it K? Now, what? Only K.
Is that ESS? ESS equals
Yes.
1 by K.
1 by K. Good. It is ESS. Of course, it is ESS. So you should tell me 1 by K. Good. That is the answer. Absolutely correct. Now, I'm going to ask another guy, Adnan Islam. Adnan, are you ready?
Sir.
Okay, sir. Can you tell me what will be here? Can you see, Adnan? Okay.
No, sir.
Okay, now can you see now? This one.
Yes, sir.
Okay, what will be this?
Sir, type 1 parabolic, sir.
Yeah, type 1 parabolic. So what will be the steady state error you written in your paper? Then I'm not going back.
Infinity, sir.
It is infinity. I'm asking everybody, is he correct or not?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir. He said it is infinity. Okay, fine. That's great. Now I'm asking another duck. Please don't leave the room. No marks for it. Even no performance. I'm just checking that you are busy with something else, watching movie, or you are here with me online. Sharif lost already. Sharif Ahmed.
Yes, sir.
Okay, good. Sharif, can you tell me? I'm sorry. Sharif, can you can you tell me what is here? Okay, I'm thinking you cannot say. Okay, what is here?
Sir, parabolic so type 2.
Yeah. What will be the steady state error?
Type 2, sir, 1 by K.
1 by K. You said it is 1 by K. Is he correct or not?
Yes, sir.
Okay, good. Excellent. Now I am asking one duck. Saida Amanna Sadia. Sadia, you are caught. Are you
Yes, sir.
scared? Okay, good. Now you tell me, Sadia, what will be the thing here? Over here.
It is type 0 step, and the answer would be 1 by 1 plus K.
Beauty. Excellent. That's the answer. I think all of you are on track. Hopefully, that is good. It is 1 by 1 plus K. Good. Excellent. Now, next, Atikur Rahman. Sleeping already. Atik. Atikur Rahman is having dinner, maybe. Atik, are you there? Okay. Atikur Rahman? All right, no problem. Now maybe, okay. Who wants to, okay, anybody, just voluntary, I can understand it. You are not in the mood to answer. I'm just asking open question, and all of you please try to understand. Anybody can tell me what will be this?
Infinity. 0, sir.
It is 0. And everybody check is correct or not. Okay, what will be this here? Ramp and 0.
Infinity.
Sir, infinity.
Infinity. What will be parabolic?
Infinity.
Infinity, sir.
Infinity. And what will be here? Step
0.
0. And what will be this?
0.
0.
0. So now I want to ask you, who can answer what will be here?
0.
Sir, 0.
Good,
Type 3
absolutely
or
great.
0.
That means you understand. It is a type 3 system for parabolic input. It is 0. And what will be here? What will be here?
Sir, 0.
Also 0.
0.
0, sir.
The higher the type, the steady state error goes to 0, 0, 0. Got my points? So we can say the steady state conclusion is steady state error is going down with the increasing of type. The type is increasing, the steady state error is decreasing. That is the conclusion we can say. Now, I hope that you all understand what does it means. It means if we apply in a system where we apply a step input, if it is a type 0 system, then the response will be like this. The response will be having some error here. That means there will be some steady state error there. If it is a type 0 system with steady state, but if it is a type 1 system, then it will be 0 steady state error, which is a servo system, you can see also. So if it is a servo system, input is a step input, output will be like this, and it will be mixed up with the input. There is no error coming there. That's the thing. And you go for type 2, type 3, all if you apply the step input, if it's a similar way as a ramp input you apply, if it is a type 2 system, it will be good. Type 2 system, the ramp output will be coming like this, and make it just 0. But if it is a type 1 system, then the ramp input, if you apply, then the output will be like this, and then there will be a constant error coming here. But if you apply a ramp input for a type 0 system, then steady state error is infinity. Infinity means what? If steady state error infinity means, or this one I'm talking about, of a ramp input, if you apply, not this one. I'm talking infinity ramp input, means that the guy is applying ting 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 infinite, means the unstable. Infinity output means infinity error means you understand it has become unstable system. So this is the case here, just for a graphical representation I'm showing you here. Okay, I hope that all of you understand the meaning of this thing, and we are finishing. I'm not going to do anymore. It is already done. So all what we have to go for, one practice problem maybe here we can see, and if you only one, I want to show if it is okay. This is what you can do it at home. If it is there, I'll show you. Otherwise, just go. Yeah, it is there. So maybe we can see this thing, and other things you can do it at home. Look at this picture. This is the problem I'm asking you. Can you see the problem, all of you?
Yes, sir.
Yeah, this is the problem we'll solve, and then we are finishing for today's class. Okay. If you read this question, you get a snapshot. I think you can try at home. Now, if you see this question, it is first part, you have done it. Considering unity feedback control, so closed loop transfer function C by R equal to this. What you have to find is determine the open loop transfer function. I'm not asking you to do it because you have done it already. Can you remember? No, sir. Yes. Have you? G is a unity feedback. Can you remember? First class you did it. Hey, all of you sleeping?
No, sir. Yes,
Okay.
sir. No, sir.
Okay, C by R equal to what? Can you tell me? Anybody can tell me here? Hey, you should know that.
G by 1, G by 1 plus J.
G by 1 plus G. This C by R. That's the C by R is given here this. So you can write here the G over 1 plus G. C by R is this from here. Now, can you remember this type of problem you solved? Then you cross multiply with this thing, cross multiply with that thing. And from this cross multiplication, you found the G value. Can you remember?
Yes, sir.
Hey, rest of you, can you remember what I'm talking?
Yes.
No.
Yes,
Maybe
sir.
the
Yes, sir.
A B K value, maybe integer value 3 to 5 or something like that, or it can be a KB, I don't know. But you found from this cross multiply, you found the G, and that G is nothing but G and GH. That is the open loop transfer function, because H equal to what?
1.
That's
One,
right.
sir.
So your open loop transfer function means GH means G, and that G coming here. So whatever the answer you get from here, your answer is done. So the first part you did billion, trillion years ago. That means in the first class. Can you remember now? Yes.
Yes, sir.
If you cannot remember, you open
Yes, sir.
yeah, open the classroom. You can see, oh my God, we did it already. Okay, now let's come to the second part is our question here. Also find the steady state error equal to this. This is our question here. Now, anybody got the class note for the first class we did, and what was the G value we got? Can anybody remember, or can you tell me if you have it? No, it is not with you here, right? G was what?
C by E.
Yeah, no, not C by. In terms of
No, sir.
KSAB or 324, what was the question? Was it in terms of a KABS? Open loop transfer function, closed loop transfer, that class, OLTF, CLTF, that class, yeah, as a solution, practice problem I have given you.
1 by 1 plus k.
1 by 1 plus K. No. It's something like, yeah, like something like that as a K S square, S into S plus K minus A, like that. Cannot remember, right? Okay. Okay. You see the question for the class where we have studied open loop transfer function, closed loop transfer function. There, if you carry on, at the end of that class, we have solved the problem like that. Okay, you should get something like this, and then steady state error for unit ramp input you have to find. And in unit ramp input steady state error, what was that? You can just substitute the value, then you can find it. Like ESS equal to what? Limit S tends to 0, and step unit ramp means S into RS. RS means what? RS into 1 by S square and 1 plus GS. That's it. Okay, now S square cancel out to S, and we are getting it here. S is there, 1 divided by S plus SGS, right? We got it. This thing, now S limit S tends to 0. So that part S is gone. So 1 divided by limit S tends to 0. And yeah, you got it? Anybody? And S into, now we are going to substitute that S value here. And if you put that S value here, then maybe this is, I think the value was, on the top was, if you do, on the top was A minus K, you can see. And bottom is something like that. So it's a B, K, S into S plus A minus K, A minus K. So this is minus, it's minus, this is plus. This is something like that maybe. A minus K, and on the bottom is what? On the bottom is not this. Actually, I have made a mistake. On the bottom, anybody found the answer? No. On the bottom is, most probably it will find B. Maybe these values were different, is it? These values were 1, 3, 4, 5, is something like that instead of K, B, A?
Yes, sir.
Okay, what was
Yes,
that?
sir.
You just replace it. K was what? S type to the B was what?
5s plus 2 by a square plus 3s plus 2 was the function.
Okay, can
and
you tell me
answer
5S,
was
5S plus?
2 by a square minus 2s. That was the value of G.
Yeah, S square. No, I'm talking about equal. C by R equal to what?
5s plus 2
Divided by S square plus?
3s plus 2.
Yeah, that is what you should tell me. Now you compare with the, and what is the value you got? G equal to?
5s plus 2 by a square minus 2s.
Good. S square. Okay, minus 2S, right?
Yes, sir.
Minus 2S means you can have minus 5S. 5S plus what? 5S plus 3S. 5s plus 3s, right? That is what 2s plus 3s. Okay, so you can compare it. You can get something like this: g equal to then 5s. 5s means your ks plus b. 2 is b, right? This is what you get. Bs ks plus b. Okay, so you are writing here ks plus b divided by s into s minus s minus what? S plus a minus k. This is what you are getting here. Okay, now you can see your s's cancel out. S's cancel out. So what s equal to 0, if you put, what do you get? S equal to 0, then a minus k is going on the top, and bottom is k, s equal to 0, b is there. So your steady state error is coming here like this, and that is what you have to prove: steady state error equal to a minus k by b. You got it? It is proved. Hey, all of you.
Yes, sir.
Your brain was short circuited.
Yes, sir.
Okay, I understand it. It's a very simple problem. All you have to know is you have to do it. Actually, I have just directly jumping from here to there. That's why all of you are confused. But if you follow the formula and then find the g, and g equal to find this one, then you find steady state error equal to this, and that equal to this, you get, oh, it is proved already steady state error. Got it? I understand it. You all can solve this problem, and I'm going to show you the last problem. I'm not going to solve, just I'm showing you because I know you will be in trouble. Okay, look at this. This is a last problem that what you have to do. Look at it. This is a question actually, and this question is very important question. This is the problem for steady state error. All of you have to solve this problem. Answer is given here. The answer is given here. Okay, now answer I have taken off. I think should be fine, no problem. I'm just telling you this one you can find where you can find this solution. I think how to solve this problem, you can find it where you can find it this question. You can find it in the book Ogatha, page number, I cannot tell you what page number, but in steady state error chapter in the Ogatha book, if you try to find it, you can find it, and you can find the solution there also. Very, very important. If you cannot understand, you let me know, then I will explain it to you next class. That's the end of steady state error. And if you have any question, you can ask me. Otherwise, the class is over, and you all get ready for the midterm exam next day after tomorrow or something like that. You just get your preparation. Any question, anything, just call me, send me email. We can put a consultation time as well if you have a question, and you have to discuss among yourself as well. Hey, anybody got question? Otherwise we are going to close it, and those who are having question, any separate question, you can stay back and you can ask me. We'll discuss that problem. And those who are having no question, you can go and sleep or get your preparation for the midterm exam. I think that's it. Today's class is over. Thank you very much for staying with me. Just 1 minute, you stay 1 second. I'm going to get the last snap, those who are with me. Okay, last snap is this, another. Okay, you can go. I have taken the snap. So all of you.
Sir, I had a question about the servo system.
Yeah, I'm telling you to stay back. That's what I'm telling you. Those who have question, you can stay back. You stay here. Don't go. The rest of you, those who have nothing, you can drop the class. Thank you very much. So the class is over. So I'm going to take the, just a minute, is the recording off.